In this video we're going to put together some code to get the GUI from last time up and running, alright? And we'll add modifications and improvements as we go. So as you might remember, this is what we had before. Okay, we've built it to look the way we want with the input that we want. And now it's time to put some code into it. Now the main thing with the code that guide generates for us, okay, is that there's a main M file, okay, and it has the same name as your figure, and you must always keep that, the same name as your figure for the figure and the M file. Now there's all this assorted code that MATLAB has put together, and it has it at the start. 99 times out of 100 you do not want to touch any of this code, okay? The things that we want to edit, okay, are in here down below in the callbacks, okay? That's what I'm concerned about. I'm concerned about callbacks most of the time. Okay, so first things first, let's just get one going for the amplitude, okay? So let's consider it our GUI. So when we launch it, we want to have some default values in place, okay? So default values I'm going to set in the creation, okay? So I'm going to say the handles.amp is equal to, let's make 5 the default value, okay? Now let's set the edit box. So I've created a variable called handles.amp, that's a structure, okay? I'm going to set the current object, which is the edit box, and I'm going to set that string to be the number to string of handles.amp, okay? Now I've stored this amplitude variable, which I'm going to recycle and reuse all the time in my code, in the handles, because in GUIs you need to remember that the handles are passed around between every single object. Okay, so we can store common data onto this handle structure that already exists. Okay, and that's a useful feature that we can do. So if you edit the handles structure, you need to update it before you finish. Okay, so at the creation of my edit box, I'm going to make a default value. Okay, I'm going to set that value to be 5. Okay, let's do that now. So we can see that there's a 5 in here. Alright, now we want to do the same thing, okay, with all of our other edit boxes. So let's go through and look for the attenuation edit create function. Okay, let's just change that to attenuation. Let's make that 2, and we'll make, because this function is the attenuation edit create function, we keep the actual object handle the same, and that's H object, which refers to the current object we're working with. Okay, and I just update this guy. So I'm just going to go through now and look for my frequency edit create function, which is here. Frequency, let's make that 50 Hertz. So not too dissimilar to something that we have in our houses, 50 Hertz. Okay. Frequency, let's look at the phase. Okay, let's make a default phase 0 degrees. Handles.phase. Okay. Phase slider, and the time edit is the last one. I'm just going to play with the edit boxes in this video, and then we'll come back later and we can investigate the sliders. Okay. Handles.time, handles.time. Okay, So now let's just make sure it's not open already. Run it, and now we see we have the default values in here. So nothing we do is changing anything because we have no callbacks, but now we have edit boxes with default values, okay? And that looks good, okay? That looks like something that you'd use in a normal program in Windows or whatever. So now let's actually do something within the callbacks. Now we have default values. So all the values, all the parameters, amplitude, attenuation, all that sort of stuff, all the things we want, all the things we need are defined. And now we need to just consider how are we going to react once one of these changes by an edit box change, okay? And we do that with the callbacks. So let's just look at the first one, amp edit callback. So basically we just want to use this function, so I'm just going to copy it. So I'm copying the function definition because this is how we use the function. I've defined it as being called this, it has these inputs, okay? And it has outputs E and H. So to use the function, we pretty much use it the exact same way, except here we have handles.amp, here we have handles.att, handles.frequency. I'm just going to chuck. Don't worry about that, that's just changing the angle so it's in terms of radians, okay? So before it was the number that we input as a frequency in hertz, and now I just want to get it into radians per second. So that's no big deal. The point is that we're using the variable in the handles structure. Now with time, I'm going to create a vector between handles time with 1,000 points. Okay, semicolon so it doesn't print. So this value here is our, if I can actually select it properly, is our t vector. So it starts from 0, it goes up to handles.time, which is our maximum time value, and there's steps of the maximum value divided by 1,000, okay? So we should get reasonable accuracy out of that. So now we have generated the actual E and H ones. Let's consider plotting E handles.e plot. This is our time vector. Let's plot that against E with red. Okay. Now the main, what have I forgotten? Okay, I've gone straight into the callback, and I've gone straight into using some sort of function I've written before, and some sort of output processing, but I've forgotten to actually get the new value of our edit box. Okay. So this is the amplitude edit box. So handles.amp is equal to I've had to use the string to double function because notice here in the hints that they provide, it says that it returns the contents as text. So I need to convert the text to a number, and I give that number now to handles.amp, which I then use in here. Okay. Let's do the same here. Let's just copy this over. Handles.bplot, and I'm going to plot B with black. Okay, so let's give that a whirl. Let's make it 10. Okay, and now we see we've got the electric field up here, but something's gone wrong. So I've put something in wrong here. So notice how I've used H, I've used B instead. That was a typo. So let's close this off. It's a good idea to just close the GUI each time you run it, just in case. Now let's run it. Didn't like that again. Let's see what's up. Okay. Because now B plot didn't exist, okay. I'm getting mixed up with my B's and my H's, okay. So, okay, let's run that. Okay, eventually we got there, okay. Alright, so now we have the graphs as we want, alright. Now let's just tidy these up. The label is time in seconds. And the Y label is electric field, and the units are volt per meter. Okay, let's copy that down. Let's just copy that into here. H plot, and let's just make that magnetic field in the units of amperes per meter. Let's run that now. Okay, now we have the electric field here, the magnetic field, amps per meter, and now we can resize all these because we've told MATLAB that's what we want. We want our window box to be resizable with normalized units, so we can see that's doing its thing, which is good. One thing we should do is let's just move this up a bit, move this down a little bit, just so, we'll just run it from here, just so when we use these, now this one's being cut off, so you just need to fiddle around a little bit, okay, until we see all the text, all good, okay, so that's starting to look a bit better, okay. So now we have the guts of the program working in here with the edit boxes. So we retrieve the value from our edit box. We do that by accessing the properties of the object. The properties of the object are what's important, and that's what defines it. And the particular property that defines the value in the edit box is the string. Okay, with sliders it's the value. With edit boxes we want the string. We get the string by the get command, and likewise we can set it just like we did with the create function. We can set it, okay? So we get and we set values, okay? And inside our callback we have our main function. So all this is going to be stock standard for every edit box callback, okay? All we need to do is change the value that we're getting. Okay, so let's just try that now. So let's just copy that down to the next one, the next edit box. That's this guy. So the new attenuation value is the new edit box number. Let's do it for the frequency. So we call, and you'll find that with these GUIs and with ones like this where there's multiple input controlling the same sort of output, a lot of what you're going to write is very repetitive. And so I apologize if these videos get a bit more boring than usual. But it's a fairly repetitive process, and I think you just need to dive in, build your own, okay, and hopefully it comes out okay for you. So now we've put it in here, we've repeated each of these, so we can now, let's vary that down to 2. We see the axes have changed, okay, attenuation, so we've attenuated it. By attenuation I mean I've increased the resistance or something, so we see it's looking like that. Let's increase the frequency to 100, okay, Let's offset the phase by 90 degrees. Okay. Okay. So all these edit boxes work. So we're going to come back and look at the sliders and how we can get the sliders to talk to the edit boxes so it looks like a interactive program.